And I jump right into page 38 of the minutes approval, dated October 13th, 2020, phase 2A scope of work. First floor exploratory demolition. I had to fix the mic there, sorry. First floor exploratory demolition. CPR at the direction of MC perform exploratory demolition at the locations indicated in phase 2 contract documents. A total of 5 areas of exploratory demolition were performed, and that would be these type of holes, I believe. It's one more than initially contracted, each approximately 3 by 3 in size. At the various exploratory locations, the contractor demolished the paver system at the pool deck, calls them pavers there, stamped concrete at the parking drive, and removed landscaping within planters down to the existing waterproofing, and remove landscaping within planters down to existing waterproofing. So he did not. So there is waterproofing inside these these planter boxes, and he removed it down to that, and then he stopped because he didn't. Obviously, the planters boxes still had good waterproofing to some degree, and that's why he didn't go any further. Apparently, this initial work yielded some quote curious results end quote right there. It's all quoted, but I wanted to double quote that as it pertained to the structural slab's depth. And we go over the depth in the first video, I think. I've done so many versions of this. Hopefully, maybe I'll hit on it again. And MC requested that additional core work be performed by CPR to confirm / clear up said results. This curious results. CPR performed 6 separate cores at the direction of MC. So initially, there was one more than initiated contract of the exploratory holes, right? And they performed 6 core samples at the direction of MC. The results of the exploratory demolition and the additional core work are summarized in the attachment CTS, which stands for what? CTS, see you Tuesday, Saturday, Champlain Towers South. Test probe notes file. Okay. So I'm going back to this again, and I already went over that. The location per the drawings are not jiving exactly. This is the laser. This board helps him find the laser. Otherwise, you'll be hunting for it forever. Apparently, the laser struck there, and he was able to do his depths from the laser that's mounted like right here and at a site here. We're not privy to that laser touch off. This is what I find very interesting is that this steel has been drilled through, including this, what presents as like maybe a stirrup steel. I've never seen a chair like that, so I'm going to call it like a stirrup steel. And I could be wrong, but that steel is. Oh, I'm sorry, I'm not wrong. It is a stirrup steel, but what capacity is it used in? Is this a slab drop repair that was done at one point? I don't see the cuts that would indicate that. This looks like this was all one and done, this depth. So I don't see that this was a secondary repair, although I see steel at the bottom of this one. Curious results again. But yet we see no steel here. So I understand that these samples can give you I like curious results. You know, they really are quite profound. Zooming in on the steel itself, it's not swelling. It doesn't. It looks like it has paste on it. It's not. Well, part of it is probably use a wet saw, but a wet drilling method. So that puts some paste cream over top of it. But this profile here still presents as such. The shape of this is, you can see the grinding took place with that rib in the steel that I showed you before. That rib design took place. This is a. Could this have, could this have some reinforcement, a slab drop added, and then this type of hook to tie it to the top was placed? Well, I need to see the seam. I don't see a seam here. See if I can go over one. So structural plans, yeah, it would jump there. So let's see, page, Champlain Towers. Okay, so I think it's page 8. I've written a lot of notes to hopefully make this go faster. So I'll scroll through this and talk. So there is the preliminary 30-year plan. And right here, of all places, this person said, I want to test probe here, test probe A. And this is the results. What are the odds that they pick that location? Well, I think that there's indication that the BMA had fractures in it. Fractures in it right here. The BMAs, beam type A, the BMAs, they're poured that there wasn't enough steel in this to handle the deflection that took place thereupon, I would say, right here. And this steel across the bottom was enough, and these stirrups were not enough. So, but this would indicate, watch what I'm going to do here, and you guys will be surprised. You know I do the Columbo trick. Incidentally, because you guys said Columbo to me a few times, I now have learned, somebody sent me a beautiful link on how to learn the algorithm and things like that. And so I'm still learning it. But 4% of my content now comes from people watching Columbo, 3.8% to be more specific per Google. I find that very amazing, right? So you guys saying the comments actually directs the traffic from those other places back to me. So please keep commenting. I told you I said I'm going to learn this algorithm thing. That's what I do. I figure out things. So your comments are great. So please keep telling me the commercials, and please comment on Lowe's and Home Depot. Let's see if I can pull some traffic from Lowe's and Home Depot advertising over here. So yeah, let's have a little fun. Let's have a little fun, guys. Let's see if we can, with the algorithm, bring some Lowe's and Home Depot traffic over here. Yeah, don't mess with me, right? I'm not someone to be played with. I know how to attack back. So please help me out with that. All right, so this would indicate, watch what I do here. So I give and I take. You know the way I do it. I'm great, give and take, baby. I'm great, Austin Powers, give and take. I'm gonna do something nasty here. So I have a crack, 2 cracks here. Each of them are open. Well, this goes down like that. It creates if it did that, it can create a compressive moment here. Let me bounce back the arrow out for you. So right there would be a compressive moment. It would compact that. It would also be putting tension in that steel there. But we have a full crack. So we have some pulling away. We got some direction that says already that this BMA is pulling away from the existing structure. Not for free. If it pulls here, we already have indication if that is the beams above, and we use the slab drops connection as part of this. Whoa, back that out. So if I use the slab drop, let's go. It won't let me do it that way. So let's do this. Thank you. If I use a slab drop like this, and let's slab drop it. This is 13.4 inside, and I connect here. We already see that this is the stress. Something's pulling away from the structure to create an open, even crack like this. It's pulling away. It's connected to the BMA, the columns here. That creates a torque action in our BMA here. So that's a torque action, a rotation. Let's see. So it would be going. Okay, so I don't want to confuse you. So there's a clockwise torque, right? And there's a counterclockwise torque. So if this is pulling away towards the swimming pool area, this would be tipping over there. So the rotation would look like that from the swimming pool direction. So this would pull, this section pulling away, would give us our separation here. It would also give us a pulling on the transfer slab, also the separation there. To prove that, we would have to go start looking for cracks at the face of the structure. But very small indeed, because we have separation cracks here, right? Separation anxiety. And doing that rotation like that, it's connected to the columns. This could create our stresses in here where we get a full crack. Ideally, we want to see on this side a compressive crack, so it would be a smaller crack, say like that. Visually, you would see that. And over here, we would see, I'm sorry, so I got to flip that around. So on this side, you would see compressive or spalling spalling on this side, right? We would see on this side a little bit of spalling action because it's getting closer and tighter, rotating. And on this side, we would see more of an open crack, and I'm exaggerating the openness, if you will. So one side, not for free, everything's got to meet equilibrium. You pull on that, you're also going to be stressing this. But our crack presents not going through here. So our rotation is kind of a weird rotation. It's actually opposite because this crack is open here. It doesn't go all the way through. So this means that if I had this pulling this way, I've got an opening here. Open means tension. So that means to get a tension, I have to have a pulling force that would do that. So now I have a pulling force or a rotation force. Same thing, it's a pulling force. If this doesn't go all the way through and it's open, this rotation, this steel could be engulfed inside the columns. That would give it an anchor point. And so even though I get a rotation, this should close up a bit if the rotation is in this capacity. Right? Let's get rid of that one and do more of a clock rotation. So the rotation would be a compressive moment on this side. I believe this is the pull side. Or is it not? Is this the okay, so whichever one this is, I'm trying to show you what's going on here. That first off, we do have a pulling moment here. We don't have a up and down, so they're not describing the deck as being like this, elevated. This shows in plane. So this shows the cracks are in plane, so we don't have any sinking going on. All his cracks show in plane. We have a pulling. I can get pulling here. I can get the separation here. It's in plane still, so that's why I have it pulling and not up and down. It didn't say grind surface to make even. It does not detail that. So this is it presents with the data that I see in front of me as a pulling action. Now, could the pulling action be this way? It sure can, but we got the building that we would be pulling, that would have to be doing the pulling at that point. And we don't have him exploring inside the cracks inside the structure. So we got to stay out on the deck. So we'll stay out on the deck. And this BMA now, perhaps we can move it to, let's move this out of the way a bit. So perhaps we can move this BMA with this rotation. Okay, so looking at my notes, I have only a few pages, guys. 15. Okay, so I'm at page 15. That's BMA. Drop panel, nothing else on 15. Go to page 17, it says. We have a column spalling. It could be just rust. That's a coupling they're going to replace. I'll talk about that. We have the critical shear area with the top steel needing repairs, a structural member being shored while it's being done. It could be for safety reasons, because while you're doing it, why not secure it? This would tell you that if he's not securing underneath of here, that this BMA is considered to be sound. It's like, now this is transferring the load on this side. It's transferring the load down 2 columns. I consider it to be sound. So it would be, right. Drawings, structural drawings, hold on. Structural drawings, structural drawings. Oh yeah, again, any of you creeps or freaks that want to freeze my page and look at what I just flashed up, I find you as like kind of a stalker, and I think you're nuts. You send me the email telling me what you saw, and you send me a screenshot. I just block you, and I think you're a freak. I think you're some type of, you got some, that's clearly my intent was to work on this data here, not to share anything personal in the background. So you screenshotting, zooming in, and all that, I find you, you're just a freak. You got problems. You got mental issues. You're not doing yourself a favor for sure by being an asshole. So the structural drawings are what I'm looking for now. So back to this one. It changed my the computer's been crashing a lot, so it changed some of my windows that I had open. And I had the structural drawings up, so it looks like we're going to have to go back. You know what? This is 84 pages. I had the structural drawings up, 84 pages. So yeah, I'll edit this in round. So you put up with this. I'm going to kind of keep kind of quiet because I know I got to edit this part out, and it's going to take days for Google to edit it out. So give me a second while I navigate through this. So page, I'll navigate through trying to find the pocket over here. Let me just pull up the structural drawings. And come back in a few days, this will be edited out. Okay. Oh, I downloaded them. I forgot. I could have went to my downloads and found this because it was crashing. So I said, you know what? I'm on their cloud. Maybe they're, get off their cloud and that would work. So right here is the lobby, and we're going to use the elevations again of 1110 and 1010. You just take a foot off if you like and reduce everything. But the rotation I'm talking about. So here is a BMA, right, going this direction. This is also a BMA, beam type A, BMA, right? A BMA, this BMA, BMA, and BMA. So we could be looking at the end support when we look at. So this one has the rotation and a pulling, a separation. He doesn't show where it goes. See this detail. This detail says it's continuous, but it nevertheless has got 3 pieces of rebar on it. And interesting enough, this is this little puncture protection. It's like a stirrup design also. Goes down, up. It's doubling as a stirrup design. So any load here is actually going to have a pulling down effect of the deck, of this section here pulling down. But we have an open tension. We got a lot of interesting cracks going on here. And so we have, if it was, so over to overlay this, we have our repairs going here, and we have the other, our inspection there, and we have our other inspection hole here. Of all things, of all magical things, he nails exactly where the deck is fractured, but not over there by the pool, where he doesn't go by the pool to inspect. He does multiple inspections, but stays away from, yeah, it kicked me out, see that? He does multiple inspections, and one more page, no. So he does page 1 of 83, good. He does multiple inspections, and his multiple inspections nail exactly where the issues are by the BMA and by the structure. I believe that a survey was done, and a survey said, look, you've got some serious deflection and cracks over here. I think the smartest move is to investigate those areas. And let's investigate it with some core samples and some deck probing. The deck probing presents as, the deck probing is not that deep. So deck probing only goes to here. It's not curious to me once you pull a core sample up. It just says, all right, your top deck presents as pretty solid to a certain degree. And you didn't go below that degree, so you didn't find the next level of failure, of delamination of the bypassing materials. Let me zoom this one out. So yes, your evaluation, the evaluation here, and the photographs present as, let me zoom that one out, present as the probing, this probing area, not the core samples, present as looking pretty good right here. Look, it looks good. Well, you only made it down to your first level. You didn't even make it down past the first level of your sample. Your sample says if you would have held out and went down another couple of inches, you might have found the crack. So here's what I'm driving at. Let's get away from that one. I'm in the wrong one. The one I wanted to present was this one. So you have to go down 3.5 inches to get to the first level. 3.5 inches. So this one is not where this, it says approximate, just be clear that. This appears to be the curve, this appears to be a curve. So the sample shows you got to go down 3.5 inches to get to that one, and then 6 inches to get to the next break. So it would behoove you to go down at least 6 inches to see if you find the next fracture. There's no tape measure in here. There's just a narrative that's put out without a tape measure, without a depth being done there to like a board across it and then measure down to get your depth, your square depth. It's not presented. So here's the academic part of it. He planned on taking off the entire deck anyway. At some point, I believe the data said to him, you know what? This deck is trashed. It's too dangerous as it is. I don't know if he said dangerous or not to himself, but he said it was structurally unsound in a few places. So those places appear to present as here because this is where they were going to take shoring and they were also going to do some, this right here, this piece, this alone, and this alone also. These are full fractures and grinding. This is also where the cars were. This is where it's connected to the structure. So this is where we can get the break there. Now from here to here, tying these two together, we get the butterfly effect. It goes down. There's not much left. The butterfly effect goes all the way over to here. It's right on top of our beat. The cars go down right here about the planter boxes. We're here, baby. We're already at his failed section. You know, we're already here at his failed section when you do the butterfly. When you put the backside of the cars going down and I extend it out like that, say out to the expansion joint right there. Remember I talked about expansion joint. It turns, it goes this way. Thereabouts there. Let's change the color on that one. So the expansion joint goes there. So we're already just a crumb away from his fractured area here. And we're already at some BMAs that need some critical work done. I'm trying to zoom in for you. So we're already at a section, where is it here, that needs some critical work done. Trying to zoom out. That the BMAs are fractured, etc. So between, this is the parking garage, parking here. So we got these vehicles loading here, cycling, and you got to look up cycle loading. It's not for free. There was supposed to be a BMA across here. Remember, there was supposed to be a BMA, beam type A, going all the way across. And let's give it a different color. Let's go with something like that. There was supposed to be one there. There was supposed to be one here. Right, so that would be, well, that didn't work. It picked that shape. I'm getting spoiled. It usually knows how to triangulate my rectangles. And then there's another one here transferring the load, right? There's one that goes across to transfer the load. But the cars are supposed to come here and load the deck in this capacity. But they keep coming in there. Their flower pots, the weight of the flower pots are here. The planter boxes, they're here. And they keep coming in, surging, surging. Remember I showed you the curb weight, how increased loading goes? It's doing this. It's cycling it. All of these guys just cycling this over 40 years. Cycling, cycling, cycling. This represents the tearing of the concrete of here, the deflection that took place. It would need deflection to do this, or lateral movement. We got a wall here that's in good place, so there's no lateral buckling of the wall out here, seawall, and there's no crushing of this inside here. So we're getting deflection in the deck because this little lady's missing again. The BMA that we're supposed to tie in is missing. So we're cycling here. Let's move the BMA out of the way, but I'll keep it in your mind there. So it's cycling, coming to a stop, coming to a stop. Thereupon, a fracture, I believe, if you would have moved another core sample along this line, he might have found more fractures. If we could find out which BMA is doing the rotation, we now can figure out that this deck was deflecting or cycling and caused that fracture in the BMA, pulling on the BMA and causing those rotations and fractures on the BMAs, which the BMAs are supporting. Let's get this clear. The intent of the BMA, they hold the deck up to here. They hold the deck. See the reinforcement stops right there. So the reinforcement, let me move this out of the way. The reinforcement is a slab transfer. So go back to the structural. Where's my structural? Thank you. So going back to the structural, going back to the structural. Thanks a lot. Going back to the structural. Where the hell did they go? Wow, now I'm down to this. Looks like I lost the entire page, doesn't it, almost? Okay, wait a minute, there it is. So structural is one page over. Okay. Going back to the structural plans here, we see that, remember, this is the same level, 1111. So, and they're loading this deck. The structural plans show that the steel was going into that, right to the ledge of that deck, to the ledge of the step up. The BMA that they're repairing is either going to be this one, or is it this one here? Because he happened to pick exactly where he wanted to probe was right here. So I'm guessing it's the BMA here that needed repair. I don't think that he saw a crack in the BMA underneath, the structural repair, and said, oh, you know what, let's go ahead and take a core sample over here. No, I think it would be relative to this BMA here that he would take, that the company would do that. So I'm extrapolating. I could be wrong on that location. The reasoning why. You guys can make your own determination. And remember, I've given you a bias point now, bias point to follow. But I gave it data behind my I like to make up words so you remember it. Biasity. I'm trying to make it I'm trying to add an A in there. Biosity. That's it. Biosity. So, I love making up words to help you remember it. They're different. We do that. So we have cycling right up to here. Whoop. I'm going to end this video. Oh, well, I think I already talked about the previous video. These locations are not as he identified. There's a red, that sample shows as red in this sample here. We got this now. This is a very interesting, amazing story to tell. Why is there a stirrup inside there? Presents as a stirrup inside his sample. Why does his sample show this extra piece of steel? Why is it there? It's not extra. It's a piece of steel. Why does it show it? It appears to be 1/4 inch steel, maybe, compared to that, and that seems to be larger than 5/8, but maybe not. It's diameter-wise. It is a very telling story. I'm going to end the video with that, but that gets us here. This explains why you don't get fractures over here. It explains more the isolating and starting point of the failure over here. It shows you that the butterfly would have possibly went to here and given us our initial shaking of the deck, but stopping before it finally gets across, makes this BMA that's already structurally unsound. I believe this BMA here fail. The BMA fails, pulling on M, tugging on N, and we get the collapse of the system coming in this direction. That's the end of this video. Oh, please do help me with the comments thing. Let's have a little fun. Give me some Lowe's and Home Depot comments for fun there, but also tell me what your videos are. Tell me what's in your videos, your real commercials. That helps. Obviously, they market it that way, and it helps with the algorithm. I think I've watched now, because since doing this, just so you know, it says viewership has gone up 33%. Even though the numbers don't look like they're much to you guys, it still says it's still going up 33%. So it's working to some degree, and I've got some more tuning to do, but it's interesting. All right, hope you all understand this. While we don't get cracking out there, while we have major cracking here, it's very telling that he picked the core samples there, I believe, because he had a survey and he was addressing deflective issues. I think this engineer is pretty damn smart. I don't think he made a mistake with his core sample locations. I think he's pretty damn intelligent, and that's not an insult. I think he really is, but it appears that supports. Well, why wasn't it structurally supported is just so strange to me. In the meantime, why wasn't it addressed? That's strange to me. All right, it's just my opinion. Take care.